Hello, and welcome to Backer Breaks It Down. In this episode, we're going to explore the big three of trig functions. I'm talking about sine, cosine, and tangent. So you know what they say, let's get triggy with it. Okay, starting with tangent. If we have a right triangle, okay, and we're focusing on one of the acute angles, so in this case, angle A is going to be our angle of reference. What that means is that there is a leg that's opposite to angle A, so that's leg BC. There's a leg adjacent to angle A, and that's AC. And then, of course, there's the hypotenuse. Tangent, which is abbreviated tan, okay, is going to be the ratio of the leg opposite the angle to the leg adjacent to the angle. Okay, so opposite over adjacent, that's the ratio rule. And like over here, this is just like a really abbreviated way of expressing that rule. So T is for tangent, O for opposite, A for adjacent, because tangent is opposite over adjacent. But this is all very much dependent on the angle of reference, okay? Because you go changing that angle of reference, that's going to change your opposite and adjacent angles. For example, we're given triangle DEF. Notice it's a right triangle. Angle F is a right angle. In problem number 1, I want to find the tangent of angle D. So angle D is my angle of reference. Tangent is the opposite over the adjacent. So opposite the angle D is the side measuring 36 degrees. 36 units. The side adjacent to angle D is the 27. So tangent of angle D is equal to the ratio of 36 over 27. And if you're wondering, do we have to write that in simplest form? The answer is yes. Right? So I'd get 4/3. Okay. So that was for angle D. Problem number 2 wants us to work with angle E. Okay. So I'm going to erase my work there. And I'm going to circle angle E because that's what we're working with in problem number 2. So tangent is the opposite over the adjacent. Opposite angle E is the side measuring 27 units. Adjacent to angle E is the side measuring 36. And this would reduce down to 3/4. So notice we are not getting the same answer. And that's all because of that angle of reference. The angle of reference will determine the opposite and the adjacent sides. So that's tangent. Tangent uses the opposite and the adjacent sides of a right triangle. If you're wondering, is there a trig function that uses the hypotenuse? The answer is yes. There are 2 of them. And that would be sine and cosine. All right. So I'm still going to use angle A as my angle of reference. So sine is defined as the length of the leg opposite angle A over the length of the hypotenuse. So sine is opposite over hypotenuse. So let's try finding sine of angle D in that triangle below. Sine is the opposite over the hypotenuse. So opposite angle D is the side measuring 36 units. And the hypotenuse, well, that's the 45 side. And that's not going to change because the hypotenuse is always going to be opposite the right angle. So when I reduce this, I get 4/5. I can find sine of angle E. right? And we should probably get a different answer because if angle E is our angle of reference, the side opposite angle E is 27. The hypotenuse, well, that hasn't changed. The hypotenuse is still 45. And if we reduce this, we get 3 over 5. Right, so that's sine. So what about cosine? Okay. Cosine is the ratio of the leg adjacent to angle A over the hypotenuse. So if we focus on our angle of reference in number 3, that's angle D, the leg adjacent to that angle would be 27. And of course, the hypotenuse is 45. And yes, we reduce this. For cosine of angle E, I have to look at my diagram and see what is adjacent to angle E, and that is the side measuring 36. The hypotenuse is still 45, and then I reduce that. So these are the big three when it comes to trig relationships. We use these quite a bit, okay? And you're probably thinking, how am I going to remember these? And so this has been around for a long time because this is what I was taught too, right? And it's pronounced SOHCAHTOA. And the SO of SOHCAHTOA tells us that the sine is the opposite over the hypotenuse. So O is for opposite, H is for hypotenuse. The ka in SOHCAHTOA is for cosine. The cosine is the adjacent over the hypotenuse. And then TOA, that's all about tangent, and tangent is the opposite over the adjacent. And so this is how we can remember our big three trig ratios: sine, cosine, and tangent. And that is how Bakker breaks it down.